Hello and welcome to this video where we will solve the Leetcode problem to find the minimum number of operations to make a given array k-increasing. Firstly, let's try to understand what k-increasing means. So given an array with values 4, 1, 5, 2, 6 and 2 and with k equals 2, let's look at the subarrays starting at index 0 and increment the index by k till we reach the end of the array. So if we start at index 0, the indices are 0 to 4 and they have the values 4, 5, 6 and this array is in increasing order or non-descending order. If we start at index 1, the indices are 1, 3 and 5 and the values are 1, 2 and 2, again non-descending order. Similarly, for the remaining indices, we can see that the values are in non-descending order. When each subarray has values in non-descending order, the main array can be called k-increasing for a given value of k. The aim of this task is to find the number of steps required to make an array k-increasing. So given the same array again, but this time k equals 3, the subarrays are at index 0, we have values 4, 2, and the issue here is 2 is less than 4. Therefore, it needs one step to make it non-descending. The array at index 1 or the subarray at index 1 is fine. The subarray at index 2 has values 5 and 2 and the issue is 2 is less than 5. It again needs one step to make it non-descending. So in total, we need 2 steps to make this array k-increasing with k equals 3. Let's look at an example. Firstly, for each subarray, we need to find the longest non-descending list size. So the first subarray is 4, 2 and the longest non-descending array is 2 and its size is 1. At index 1, the subarray is 1, 6 and the longest non-descending subarray is of size 2. At index 2, the subarray is 5, 2 and the longest non-descending array is of size 1. The total of all the sizes is 4. The length of the array is 6. We subtract 4 from 6 and the output is 2. So for this array with k equals 3, we need 2 steps to make it k-increasing. Let's look at another example to understand this better. So in this example, I have an array of size 5 with elements 1, 2, 3, 4 and 2 and we have k equals 1. We will gradually build the non-descending subarray. With k equals 1, we get the non-descending subarray 1, 2, 3 and 4. And then when we get to the last element 2, since it is smaller than the last element in the subarray, we need to find a place for this element inside the subarray using a customized binary search. To keep the elements in the non-descending order, the element 2 will have to replace the element 3 in the subarray, and that will give us the new subarray 1, 2, 2, 4. And notice that the size of this subarray is 4. And then we can no longer add any more elements because we have looped through the entire array. Now, since there are no more subarrays to check, the final result will be the size of the main array, that is 5, minus the size of the subarray 4, and the result is 5 minus 4 and that is 1. We will need to use a customized binary search as we aren't just searching for a value in an array. Instead, we are searching for an index to place a value in an array. So given a sorted array 1, 2, 3, 5, 6, 7, 8, 9, 10, 11 and 12, check the position to place the value 4. So in this example, we can see that we have values from 1 to 12, but there is no 4 in there. We need to find the position in this array where we can place this value 4. So as in the usual binary search, we have the low initialized to 0, the mid to the middle of the array, and the high to the last element. The mid is used to divide the array into 2 parts. We first look if our value is in the first half, then we discard the second half. If it is in the second half, we discard the first half. So in this case, 4 is less than the middle element 7, so we discard the upper half of the array. Once we do that, then 4 is bigger than the middle element in the shortened array, and therefore we discard the lower half of the array. Then we get an even smaller array, and this time 4 is less than the middle element 6, and therefore we discard the upper half of the array. We continue this till we have low less than high. Once that condition fails, we break out of the loop, and the index position contained in the variable low is the position to place this value in the array. Now let's jump into the editor and implement the algorithm. So as the first step, I'm simply defining the variable total, which will contain the sum of the lengths of the non-descending subarrays. Next, I will define an outer loop, and in this outer loop, the index value will go from 0 to k. Inside this for loop, I will have another for loop, which will start at the index I and go all the way up to the length of the array, and it will be incremented by k. This will allow us to grab all the subarrays using the difference of k in the indexes. So if you look at the example, let's look at the last example here. Here we have k equals 3. So in our outer loop, we will go 0, 1, and 2. And in the inner loop, we will go from 4 to 2. And then when I equals 1, we will go 1, 6. Then I equals 2, we will go 5 and 2 in the inner loop. So that way we will get the subarrays. So firstly, let's define a list to store the non-descending subarray. So in this subarray, we will keep adding the next element from the main array till we hit a number less than the last element in the subarray. So in the non-descending subarray, we want to store only the numbers in our non-descending order. The moment we find an element which is not in an increasing order, then we need to find the correct place for that element in the subarray. And also, if the subarray is empty, then we can add the current element. Here we're simply checking that if the array is empty, if the subarray is empty, then we add the current element, or if the last element of the subarray is less than or equal to the current element. If these conditions do not satisfy, that means we have hit a number less than the last element in the subarray, then we need to find its rightful place in the subarray. For this, we will use our custom binary search inside of this subarray and then store this current element. Let's define a method which will help us find the index where we need to store the current element. Once we have found this index, we will simply store the current element at that position. At the end of the outer loop, we have successfully found the non-descending subarray for index I, and now we need to add its length to the total. Once we have found the total, we can simply subtract it from the length of the array and return. Now let's implement our method which helps us find the index for a value in the non-descending subarray. So for this binary search, our array must be sorted, which we have ensured by making sure that the current element is always bigger than or equal to the last element in the subarray. So we will start by creating three index values: low, high, and mid. Low is initialized with the index of the first element, and high is initialized with the index of the last element, and mid will be set to the index of the middle element. We will divide the list into two halves. If the value is present in the first half, then we will not search in the second half. And then in this case, we will reset the high index to the mid, and then that means we would be discarding the second half. Else we will reset the index low to the mid plus 1 and discard the first half. We will continue this process till the index low is less than index high. At the end, the position we want will be in the variable low. Let's calculate the mid. Finally, we return the index value at low. And thank you very much for watching. If you like this video, please consider liking and subscribing, and see you in the next video.